Hi, Assalamualaikum warahmatullahi wabarakatuh. I'm Muhammad Ikram Daniel bin Zainuddin, so I will conduct activity 3.1 for lab 8. So, let's see the instruction. This is the open loop position control. So first task is we need to construct the block diagram. So I already construct it. It will be like this. Second step is key in all the parameter value into the simulation block, and I already do it. This is all the value from the list that referred by the lab sheet. Okay. At the step 3, we need to make input value is 1 and attenuator gain value is also 1. And if input voltage and shaft motor position display shows some value, it means block diagram is function. So let's find out. We run it. Okay, so input voltage and shaft motor position give us some value, which is input voltage is 0.6111 volt and shaft motor position is 11.73 volt. So this is the graph. The red line is for shaft motor position and the blue line is for input voltage. Okay, next, for activity 8.1, number 4, what we need to do is increase step-by-step value of input angle from 0 till 10 and set attenuator gain 0. Then we observe the shaft motor position display and what happened to the system. Then we find out. Okay, at first, 0 input angle and the maintain is 0 attenuator gain. We run and we get 0 input voltage and 0 shaft motor. Then we change the value to 1 until 10. Input angle is 0.6111 volt to 1.222 volt. 3 input angle, it will be 1.833 input volt for 2.444 volt, 3.056 volt, 6, 3.667 volt, 7 input angle, it will be 4.278 volt, 8 input angle is 4.889 volt, second last is 9, it will be 5.5 volt for the input angle, and the last one 10 input angle, it will make input voltage be 6.11 volt. That's for number 4. And then the next instruction is we need to increase step by step value of attenuator gain from 0 until 10 and set input angle 0. Then we observe the shaft motor position display and what happened to the system. Okay. Oh, before I forget it, for the number 4, we change the value of input angle. And then we keep the attenuator gain as 0 value, and then the system is not functioning because there is no current through to the circuit because it will start at the attenuator gain. At number 5, we set the input angle as the maintained value and we change the attenuator gain value from 0 until 10 And let's see for the input voltage and the shaft motor position and what will happen to the system. Let's find out. At 0, 0, the value of input voltage is 0 and shaft motor position is also 0. 1 attenuator gain, also 0 volt. At 2 attenuator gain, there is also 0 volt. 3, 0, make it 4, still 0 volt. Up to 5, it's still 0 volt for the shaft motor position. 6, still same. 7, also same. 8, same. The second last, also same, and the last one is 10, also 0 volt. So we can make the conclusion this circuit is not functioning because there is no current flow to the shaft motor position, because it already started at the first step at input angle, because there is no value for that.
Okay, Assalamualaikum and hi, my name is Muhammad Syafiq bin Muhammad Asri and my number metric is DE 2072. Okay, today I want to do a simulation about lab activity 2, that is closed loop. Okay, now I show the simulation when the input angle 5, the attenuator 1. Okay, I run the simulation. The value at input voltage, we get 3.056 voltage. The shaft position is 3.927 position clockwise, and the output voltage is 2.4 voltage. Okay, next we change the value to negative 5 angle because this is anti-clockwise. When the anti-clockwise, negative 5, we get the same value but in the negative, in all the value in the negative value. Okay, next for the next angle 150, and the attenuator gain is 5. Okay, now I run the simulation. Okay, as you can see, the input voltage we get is 91.67. The output voltage is 84.61 voltage, and the shaft position is 138.5 position clockwise, in the clockwise. Okay, next we change to the negative 150 degrees. When the input angle negative 150, we get the same value but in the negative, all the answer in negative. Okay, next when we change the input angle in 360 degree, attenuator gain is 8, and then we run the simulation. We get the input voltage is 220 voltage. The output voltage is 190.6 voltage, and the shaft position motor is 311.9 degrees. Okay, next when the input angle is negative 360, and the input angle 360. Okay, we get the same value but in the negative. It means the shaft position is follow anti-clockwise. Okay, I think that's all from activity 2. Okay, thank you.